Hi, my name is Ellen, and I do a lot of weird, stupid things with Enums, and I want to teach you all about some of them so that you can also do weird, stupid things with Enums. So I would like to start with a quick preface. I want to talk a little bit about how the topic of my talk is pronounced, because there are a fair few people who pronounce it like NUM is short for number, and another fair few people who pronounce it like they're just dropping the numeration off of enumeration. Since I tend to look at it as a standalone word which is related to enumeration, but not an actual abbreviation for it, I pronounce it enum. If that's going to bother you, you may want to get up and walk out right now. Don't worry, I am not going to be mad. You're going to save yourself a lot of twitching over the next half hour or so if that's the case. But I completely see the point that you generally enumerate enum cases, so I think the other pronunciation is totally fine as well. But if you really want to know the correct pronunciation, it is exactly the same way that you pronounce this word, which is to say that no matter how you pronounce it, there will always be someone who is absolutely adamant you're pronouncing it wrong. So now that we have all of that out of the way, let's talk about what is an enum. And while the technical definition of an enum gets a little bit jargony, I prefer to think of an enum as a way to hold a list of all of the values that are possible for a given variable. So if it's got an underlying value, it's almost always a string or an integer, but it also can be completely without an underlying value. Now, there's also another type of thing that's part of an enum in some languages, including Swift, called an option set that allows you to flip bits so that by combining bits that are true, you can create a much greater set of options for configuration or potentially use combinations of options. However, I am not really going to talk about those today because I want to stay a little bit more focused on the sort of enum that can only have one possible value. Because these are conceptually similar, but they have far, far more power than I think they're being used for today. So let's go back to thinking of enums as a list of possible values for something. Now, what do I mean by that? So having a variable use an enum as its value indicates that it could be one of the things within the list. A very simple example is coming up with a list of color names based on the value of their underlying string. So this is a list of possible colors. This is not a list of every possible colors. This is certainly not a list of every possible string. There could be other colors that you use. And there are times where, particularly if there is an underlying value to your enum, a value could be something completely different from what is within your enum. For example, when you are going through and trying to figure out, okay, I've passed in a string, and that string, I want to see if it matches any of these color names that I already have, and I can return a color based on that. But if it doesn't, I need to do some kind of handling for this. And this is called a non-exhaustive handling of an enum. What I really like to use a lot is what are called exhaustive enums. Exhaustive enums basically break down and say, not just are these the possible cases, but these are the only possible cases for what I'm trying to do. So as an example, you can create an enum of traffic light colors, red, yellow, and green. If you try to do traffic light color dot blue, that's not going to work because it doesn't exist. You can't do anything other than work with these three particular cases. And when you do this, you limit the possibilities for what a color can do with your code. And one thing I think we all know as developers is that when you limit your possibilities, you limit your runtime errors. You limit the things that you might accidentally do wrong because your problem set is immediately shrunk by a significant amount. So there's a couple examples of this in both Swift and Kotlin standard libraries. In the Swift standard library, there is an enum now for a comparison result. This is basically an enum that takes the underlying values for NS comparison result, which were all constants, and transforms them into an enum. You can either have, when you compare two things, they're either ordered ascending, ordered same, or ordered descending. And there's no other possibility for what could possibly be happening here. And if you try to handle something else here, you're not going to get a comparison result back. In the Kotlin standard library, there's a public Enum class kind. I accidentally left Enum class off of this, and I'll get back to that in a minute. But you have all of these different types of classes within Kotlin, including class, interface, enum class, enum entry, annotation class, and object. If it's not one of those, it's not a type of class that Kotlin knows how to handle. And by basically saying only these things are the things that we know how to handle, they immediately reduce the size of the problem set when they say, okay, what is this class? So now that you've seen a couple of examples of how these are handled by standard libraries, how do you create your own enum? So again, going back to the traffic light example, you declare that you've got a traffic light color, and then you have the 3 cases that you want. In Swift, you can also add commas between so that you don't have to have a case on every line. There's all sorts of ways to declare it. This is the one that I personally prefer. In Kotlin, there's a thing called an Enum Class. This is a really specific type of class that allows you to say, hey, every instance that I am declaring here is an enum. And when you do that, it looks fairly similar. You don't get the word case, and you do have to use the dreaded semicolon at the end to indicate that you are done declaring things. But you still are able to say, okay, I have a traffic light color red, yellow, and green. So now that you've declared some of these cases, how do you actually use them? So the main way that you can actually use enums when you're working with them is to use either a switch statement if you're using Swift or a when statement if you're using Kotlin. So going back to the traffic light metaphor, if you're using Swift, you can use a switch statement to do different things for each case in the enum. In this case, if the traffic light is red, print stop right there. Yellow, whoa, slow down there, buddy. And green, go, go, go. And you can also say that you want multiple cases to return the same value. And if you leave off a value, it actually winds up creating an error. So here, only red and green are handled, and you will receive an error saying that you've got an unhandled case. So it really helps enforce the idea that if you're going to be doing something with an enum, you need to handle every of the possible cases that exists. Now, again, multiple cases can return the same value. I lived in Los Angeles for about 8 years, so a more accurate representation of what you're supposed to do at a traffic light there can be shown this way, which is that if the light is red, stomp on the brakes as hard as you possibly can, and if it's yellow or green, just punch it and go. Now, in Kotlin, there aren't switch statements anymore. That was a thing that existed in Java. And Kotlin is like, well, I want to do things differently than Java, and so they've turned it into a when statement. And it works basically the same. Basically, you do still have to actually give the name of the enum class so that you can access the instances that it's using. But it's something where you're able to use generally a format that you're relatively used to if you've used either Swift or Java. So what do you get for free with enums? So there's different things that actually come as part of the standard library for either Kotlin or Swift enums. And I'm going to start with Kotlin because you actually get quite a bit for free with a default enum class. So if you have an instance of an enum class, so let's say traffic light color.red, if you say traffic light color.red.name, that gives you the string value of the case's written name. And as I've noted here, this is actually a direct pull from your name. So if you have named something the shouty case Thursday, then it will give you back a string that says Thursday. Whereas if you just use traditional capitalization, it just gives you back Thursday. And instance.ordinal will actually give you the index of the case in the list of all of the cases. So what that means is that in the red, yellow, green example, if you say green.ordinal, you'll get back 2, because that is a 0 index thing, because of course it is. And you also get a lot of information from the type. So in the type, you can actually pass in a value of string, and it will return either an instance of that string, or of the enum type related to that string, which is the same name. Again, this is case sensitive, so it has to be exactly matching the name of the enum value. And then type.values actually gets you back a generated list of all of the values in an enum class, which you'll see in a little bit why that can be really, really helpful. So in Swift, what you get back from using an enum by default kind of depends, because there's not really much that's presently included out of the box for free with an enum that doesn't have an underlying value. But I talked a little bit earlier about enums with underlying values, and particularly string and integer values. And those are among the types of enums that conform to a protocol called raw representable. And what the raw representable protocol allows you to do is take an existing enum. So here's a list of a bunch of different sections in a table view. And if you decide that you want to make it a raw representable, you can say, okay, this is now a settings section int. So each of these cases conforms to raw representable and now is automatically represented as a zero index list. And if you decide, hey, I actually want to change the order of these things, you can make that change, and anything else that you've got depending on the raw value of this doesn't need to do anything if it's not actually hard coding the number 0 or the number 1. And that way, you don't necessarily need to do anything. Again, similar to some of what Kotlin can do based on the name of the enum case, in a string enum, you can pass in a settings section with a raw value of 10. And if you don't have 10 cases, or I guess 11 cases since that's the index, then it will just say, oh, this section doesn't exist, and it'll return nil. And so that way you can really, really easily see what are the different things that I'm trying to handle here. In addition, strings with underlying, enums with underlying string values allow you to automatically get the string name as the raw value of the case. And you can also provide different underlying values for each case. So one of the really great examples of how powerful this is Swift's Codable functionality. You're able to basically declare this very specific type of enum called a coding keys, and it has to conform to a protocol called coding key. And when you do this in something that is marked as codable, it will automatically map everything from the username coding key to the username value without you actually having to write all the stuff that generally you do when you're parsing. So that's really, really, really sweet. Another thing that's really nice that's coming very soon is something called case iterable. And in this case, if you have that same settings section and you declare that it conforms to case iterable, you automatically have an array generated of all of the cases of settings section. And what that allows you to do is go ahead and say, okay, how many sections are in my table view? Well, I'll do settings section.allcases.count. And that way, if you add or remove a section, you don't actually have to change the number of sections in your table view. You also don't have to change how you access the title, because if you're accessing information about a particular information about a particular section, all you have to do is just get the reference to the section, and everything will still work completely as you want it to. So one thing that you might notice here is that section.localizeTitle thing. And that's something that gives a little bit of an idea of some stuff that you can do, which is add things to your enums, making them more powerful and having them do what you want them to do. So one of the most powerful things that you can do in both Swift and Kotlin is to add computed properties. It's the same way that you can add read-only properties at runtime to other classes and structures, and you can also add these to enums and enum classes. So what does this look like? So let's say you have a fairly simple enum listing the 3 buttons that are on your splash screen: sign in, sign up, view terms. One thing you might want to do is give information about what the title should be for that button. So to do that, you can add a computed property which gives you the localized title for each button. Now, this is really, really useful for configuring UI. And if you make it public, then you can reuse these values and these limitations and their values for things like UI testing. When you're working with Swift and XCUI, the problem is that you can't actually access anything using @testable imports. So basically, if you're using XCUI, you have no idea what is actually happening within your application at a live point. But if you're publicly making these enums available, you can start to switch between, hey, here are the things that I need to test. It's helpful for figuring out, okay, I need to deal with a particular landing screen button. Which one do I want? What is its title? And then that way, you don't have to change the localized string every single time that you need to access it. You can also test in multiple different languages. When you change copy, you don't have to change what you're looking for in your UI tests. It's really, really, really helpful. Again, Kotlin and Espresso, same thing. You can really easily, you don't have the same limitations that you do with Swift in terms of having UI be in a completely separate, UI tests run in a totally separate process, but you can use this to do things like help generate a robot pattern, help generate something that helps you figure out what are the things that I need to test, what are the things that are even possible to do on this screen. Another thing that's really, really, really useful is using this to help do things like get assets on iOS. Now, on Android, you have the r.whatever system, which makes it really, really easy to not hard code strings everywhere. In iOS, there are these things called asset catalogs. And you have the ability to sort of say, okay, I'm going to name all of these various things. And previously, you would say, okay, I'm going to use this raw string, cinnamon rolls, in order to try to get this lovely picture of my cats curled up like cinnamon rolls. And the problem is that if you try to do that and you maybe misspell the string, or maybe you spell it correctly and you didn't spell it correctly when you actually named the thing, then you wind up not actually getting the image, and if you're not force unwrapping, you've got no image and you have no idea why. And then if you use an asset enum for this, you can actually use that string value to pass into UI image self.raw value and then force unwrap. So you can have that so that at runtime, either you'll get an immediate crash when you're trying to access something and you'll at least know it's gone, or you will know that it's not something that's being properly handled. The other thing that you can do with this is you can add tests to make sure that the image for all of your cases is non-nil, which is really, really awesome. And when case iterable lands, because then you can use the all cases static var to not need to hard code each and every one of your cases. This becomes way easier to cover an increasingly large enum with this. You don't have to add tests for every individual thing that you've added. You just have to add one test that goes through all of the things that you've added. And that is super awesome. So if you want to do this, or anything which can be generated from an existing file or set of folders, I really, really recommend that you use code generation. This metaprogramming stuff is really helpful because if you have a spelling inaccuracy, it's the same inaccuracy everywhere. But it's also mostly because keeping these sort of enums up to date can get really annoying as your project gets bigger and bigger and bigger. I was working on an example application for this talk, and even the small number of localized strings that I was centralizing for basically a toy app got unbelievably annoying to continue to maintain. So if you're using the code generation, you can be assured that the compiler will complain really, really loudly if you remove something that you're actually using. And there's tons of cool tools for this in Kotlin and Java. There are just entire talks on how to do this. There are 3 that I want to mention for the ecosystem in Swift because that is such a newer ecosystem. The first is called SwiftGen. It takes asset catalogs, localized strings, and storyboard segue identifiers and cell identifiers, turns them into enums. Sorcery uses metaprogramming to allow generated code based on existing code. I've actually seen some really neat stuff where someone basically used if-defing of the Swift compiler in order to say, okay, if case iterable has finally landed, then use the default implementation. Otherwise, generate all of the cases that are going to be in a case iterable case. So it's really, really sweet for being able to say, hey, that sounds like a good idea. Why do I need to wait for it? Stencil is also really awesome. It's a tool that actually underlies both of those tools, and it's just raw templating. And you can basically hand it anything and make it do whatever you want. So it's pretty sweet. Bending enums to your will. There are a lot of other things that you can do to sort of make everything do what you want it to. A big one is combining protocols and interfaces. Particularly in Swift with protocol-oriented programming, you get some really, really neat tools to be able to do this. So previously in Swift, again, you wind up with this terrible hard-coded string in order to sign into an application. And then, instead of doing that, you can have, let's say this is generated by SwiftGen. This is something where it goes through and it looks at all of the possible storyboard segues that you have, puts them into one enum, and says, okay, go ahead and generate them. And that's nice, because then you don't have to have that hard-coded string anymore. Another thing that's kind of cool is being able to have a protocol where you can say, okay, something is segue performing. And here, one thing that you'll notice is that it has a single qualification, which is that the raw value is a string that has a getter. This is basically cheating, because this is a way of saying, I want this to have the same qualifications as a string enum. So as an enum with a string raw representable value. And then that way, as you learn to cheat, the only thing that you actually have to do is pass in this thing that says segue.raw value. And it will already know that that is a string, and it's passing the string that it's receiving in there. And by using a generic extension function, you're able to say, okay, anything that conforms to segue performing, if I pass it into this generic extension function, it actually will perform the segue and allow me to use that raw value. And then I can also leave off the sender option if I want to. And then go back to your enum. You say, okay, this is a string enum, so it already qualifies for the segue performing protocol. I just need to explicitly annotate it as segue performing. And then you go back into your sign-in code, and you're able to say, okay, self.perform main storyboard segue.toCats. And at that point, you've now taken all of the stringly typed code out of your application. You've said, I want to be able to know, hey, if somebody messes around with the name of something, I want my code to not even compile. I want this to be something that's really, really obvious. So again, another thing that's really, really nice about being able to tweak enums to your will is associated objects. If you have something where you want things to work together, Swift, it's really easy. You can just add variable values to this. Doing this does get you out of, you can't conform to case iterable unless you provide a default value. In Kotlin, you can actually pass in strings, and you can, or you can pass in a variable with your enum class, but every single case has to have that same variable. If it's going to be different, it's not possible to do that with an enum class. So there's a different thing to do that. It's called sealed class. And so what this is doing is saying that only the subclasses that I declare here can exist as subclasses of download state with info, so that later if I want to switch on download state with info, I at least know that I'm getting one of these things. So I can say, okay, a download hadn't started. A download is downloading with an amount of progress. It succeeded, or it failed. And you can do some neato black magic with generics in order to make this work. So as an example, the guys that I'm working with on an Android project right now had to add a custom keyboard for reasons. And they decided that it needed to support multiple different types of entry. So you had QWERTY, all these different ones. And they wanted, when you get to the end of Azerty, for it to go back around to QWERTY. And I think there's a really great way to do that, and that's using reified types and generics. So an inline function with a reified type basically allows you to say, hey, Kotlin normally does type erasure. Can you hang on to the type information of this for me? Because I actually kind of need to use that. And then you can use this lovely all values function in order to get the information about what all of the values are of your reified type. Then, if you've got that information, then you're able to say, okay, if it's greater than all values.size, then you go to the next index. And that means that you can do that on any enum. And it's not just this one, which is pretty awesome. So that now, as you go through that loop, as you go through each of the cases, you're actually going, basically, in a circle. And this is a really, really, really awesome tool set to be able to use. There are some limits to it. So as you get into more complicated pieces of the pie and try to put them together, it doesn't always work. Associated objects are awesome, and listability is awesome. Listability and associated objects does not work. As you can see, with this Kotlin sealed class, if I try to say, okay, download state within info, not started, not next, it'll wind up going to downloading, but I won't have any value for progress. I won't have any idea what the hell next is supposed to be, and then that won't compile. So it's also really, really easy to get carried away. Here you can set up a computed property that's inherently related to the thing that a button is for, but you can also go way over the top. And if you try to add click handling, then it's like, well, wait a minute, shouldn't that actually be in the view controller? And the thing is that this all boils down to a single question, which is this functionality inherently related to the thing I'm representing? If it is, then computed property or function. If not, there's probably a better place to put it, because one thing to remember is that even with enums, separation of concerns still applies. If you go too nuts with the power that some of these new tools with enums give you, you're going to wind up with some serious spaghetti code. So I have a nice young man who's trying to encourage me to wrap it up, so I've now gotten to the obligatory summary slide. So I just want to talk a little bit about some of the things that I find the most important on this. Enums are a really awesome way to represent distinct state. They will show you what are the possibilities and potentially what are the only possibilities for a particular type of value. Limit your cases and limit your bugs. If you can only give a particular limited type of thing as a parameter, you're done. Nobody who's even calling this can mess it up by accident. They have to basically mess it up on purpose. Value that's determined by the current case is a computed variable, but don't go too nuts on that. You just make sure that you're thinking rationally about what is actually related to the current case and what is not. Generated enums. Get rid of stringly typed code. It's terrible. It breaks all the time. I hate it. I've broken so many things with it, and that's why I hate it so much. And finally, again, don't forget about separation of concerns. That is the key to going from using this without abusing it. So I do have a few examples of code in Swift and Kotlin. I'm going to leave this URL up. I'm also going to post these slides because I know it's going real fast. If anybody has any questions, we have possibly 30 seconds left for questions. But I'm always happy to answer questions. I'm on Twitter at @DesignakedNerd. So thank you.
Have a big applause. So we have a few minutes for questions.
Yeah.
If you want to enter questions now, just go to Slido, enter questions, and maybe we can have the questions we have. Do we have questions?
Yeah, I'm sure people have plenty of questions, but I don't know if
yeah, here we have it.
Okay.
So maybe...
So there's slides are being shared somewhere. They'll be on speaker deck. I'll tweet that out in a little bit. Let's see, what could be tricky when using enums? I think there are a number of things that are very difficult about sort of knowing when having a limited set of options is good versus having a more generic type. Like, when do you want to use an enum with an underlying string value versus when do you actually want to just use a string? And then, the
beginner's mistakes.
Beginner's mistakes. I think Often a common beginner's mistake is to not remember that there are things where if you're not actually creating a if you're not actually checking to make sure, especially if something is an enum with an underlying value, if you're not checking to make sure that it's actually there, you're going to wind up with something that you can't actually handle, and occasionally it will even crash. So just be aware of when things are only within the set of values that you have versus probably only in the set of values which you're giving.
Thank you. One last question, and I think that's interesting. Is there a performance hit? Is it good to use enums for performance, or are they slowing down things?
Particularly in Android, there's a long-standing debate about whether you should use enums because they do take up more space than raw values. Personally, I am of the opinion that the performance hit is low enough that pretty much any modern processor will make it completely negligible, and it will save you from making mistakes that affect your users. And if you can do that, that's probably a much, much better thing to concern yourself with than a really, really tiny performance hit.
Thank you, Ellen.
Right.
Big applause,
Thanks,
please.
everybody.